Page 2 starts out with simplifying these radicals. So as far as simplifying an expression like this, what you need to do is, first off, don't just be like, okay, I can't because I can't add and subtract these because this has got an 8 and this has got a 300, okay? You have to think, what are there, what are the possibilities? Could I simplify this? Could I rewrite them as a power, the same base? 8 is 2 cubed, but 300 is not 2 to some power, so I know that I can still simplify it with the square root, so I'm going to try that, okay? And even if you can't simplify them all, that's okay. You can still simplify some of them with each other, and that is still simplifying the expression. So I know that 8, I'm taking the square root, right? So I know 4 goes into it twice, and so the square root of 4 is 2, and I'm left with the 2, but I've got a 10 already on the outside, so that is 20 square roots of 2. Okay? 300. I know 100 is a perfect square. 100 goes into it 3 times. And if you thought 25, then you'd have to then do 4 as well later on. So it's easier if you just find the largest one first. The square root of 100 is 10, and there isn't a square root of 3. So that stays inside. I've already got a negative 3 on the outside, though, so that's negative 30 square roots of 3. 3, sorry. And then 50 is 25 times 2, so the square root of 25 is 5, and there isn't a square root of 2, so I've got negative 8 times 5, that's a negative 40 square roots of 2, which means 2 of these have the same base, so I can combine those. 20 minus 40 is negative 20 square roots of 2. So I think of it as 20 of these minus 40 of these is negative 20 of these, and then minus 30 square roots of 3, and that is my answer. On 19, when you are trying to rationalize an expression with a single square root in the denominator, it is not good enough to just multiply by the square root of 6. Then you distribute, you've got a 4 square roots of 6, you didn't simplify anything. And I furthermore cannot simplify any of these out. 4 divided by 4 is 1, I agree. But a lot of you would just get rid of it, first off. But then also, you can't just simplify like that when you're adding and subtracting. It does not work out algebraically the same way. So please do not cancel out the 4s. Do not cancel out the square root of 6s. Unless it was 4 times divided by 4 times. Then yes, of course, that would be 1. Alright, so in order to rationalize, I have to multiply by the conjugate of the denominator, which means I need to multiply by 4 plus the square root of 6 in the numerator and denominator. So let's multiply this out. So first I've got, we'll go denominator first, because I have a lot of people that just mark it out like it doesn't matter. But you actually get some numbers on there, and that's the point. 4 times 4 is 16. 4 times the square root of 6 is 4 square roots of 6, and we're adding. Now we distribute the negative square root of 6. Negative square root of 6 times 4 is negative 4 times the square root of 6. And negative square root of 6 times positive square root of 6 is negative 6. So a negative square root of 6 times a positive square root of 6 is a negative square root of 36, which is a negative 6, okay? Or the negative square root of 6 squared. So now we multiply out the numerator. Again, 4 times 4 is 16. Now we've got 4 times the square root of 6, which is 4 square roots of 6. Then we have square root of 6 times 4, which is another positive 4 square roots of 6, which means they'll combine, not cancel out. And then we have, let's see, square root of 6 times a positive square root of 6 is a positive 6. So as far as what simplifies, or what happens, in my numerator, I've got 16 plus 6, which is 22. And then I've got 4 square roots of 6 plus 4 square roots of 6. That is 8 square roots of 6. Okay? Divided by, now I have 16 plus 4 square roots of 6 minus 4 square roots of 6 minus 6. Those two simplify out. And then I've got 16 minus 6, which is 10. What I notice is that 22, 8, and 10, which are all the coefficients of that, of the expression. Well, okay, they're not all. Never mind. But I notice that these three numbers are all divisible by 2. And the reason why I can simplify all three of these out is because I could factor a 2 out of the numerator, and I'm left with 11 plus 4 square roots of 6, so I divided both of these by 2 and put it out. And then, see how it's now multiplication and division? 2 times this divided by 10. Well, 2/10 is 1/5. So I might as well just be saying 11 plus 4 square roots of 6 divided by 5. But that's the same. As long as you know it works that way, then you can just say, hey, this, and this all divide by 2. 11, 4, and 5. Okay? And that is my final answer. And the reason why the 6 doesn't simplify is this is 8 times the square root of 6. So if I divide 8 square roots of 6 by 2, I wouldn't say both 8 and square root of 6 are divided by 2. It's just the whole term. So this is 2 times 4 times the square root of 6 divided by 2. Just one set of 2's. Simplify out. Furthermore, you can divide a square root by a non-square root. Alright, so again, we need to multiply by the conjugate. So the coefficient. Alright, so we multiply by 5 minus 3 square roots of 5 in the numerator and denominator. 5 minus 3 square roots of 5. And we're going to see what this gets us. So first I'm going to distribute the 2 in the numerator. So I've got 2 times 5 is 10. 2 times a negative 3 square roots of 5 is a negative 6 square roots of 5. Square root of 5 times 5 is just 5 square roots of 5. And then square root of 5 times negative 3 square roots of 5. Square root of 5 times negative 3 square roots of 5 is just like 1 times negative 3. And then square root of 5 times square root of 5 is 5. So that is negative 15. So we'll just multiply that out. And then in the denominator, we have 5 times 5, which is 25. 5 times negative 3 square roots of 5 is negative 15 square roots of 5. 3 square roots of 5 times 5 is positive 15 square roots of 5. And then 3 square roots of 5 times a negative 3 square roots of 5 is negative 9 times 5, because the square root of 5 times square root of 5 is 5. So that is negative 45. Now, if you already know that the two middle terms cancel out, you can just multiply the first two terms and the last two terms. If you know that the middle ones cancel each other out, you can do that. Okay, so we simplify. In the numerator, I've got 10 minus 15, which is negative 5. And then I've got negative 6 square roots of 5 plus 5 square roots of 5. That is negative 1 square roots of 5, or negative square root of 5. Divided by. These two simplify out, and I've got 25 minus 45, which is negative 20. And here's the thing. I do not want your final expressions to have a negative in the denominator, so you need to divide out a negative, or float the negative to the top. If you float the negative to the top, then that basically means you change all the signs. So it becomes 5 plus the square root of 5 divided by 20. And that would be my final answer. Now, I do agree that 5 and 20 do simplify with each other. But 5 plus the square root of 5 over 20 does not simplify as a whole expression. I could simplify if I broke it up. 5 divided by 20 plus the square root of 5 divided by 20. Because I could then say that's 1/4. But that's still divided by 20. And people that go ahead and say that's 1 and that's 4, you're saying this is now divided by 4 for no reason. Okay? If I had 5 plus 3 divided by 20, that is 8/20ths, which is, it divides by 4, 2/5. Yeah? Okay. If you said that that's equivalent to this, 1 plus 4 divided by, 1 plus 3, and then divided by 4, then you're saying that's equivalent to 4/4, which is 1. 1 and 2/5 are, in fact, not the same. Okay? So you cannot do that. You cannot simplify. If this had an 8 in the front of it, no, just kidding, not an 8. If it had a 10 in front of it, 5, 10, and 20, yes, I could have divided them all by 5, but I can't. Okay? Number 21. So number 21, we've got square roots again. We need to simplify. 48 is not a perfect square, but I know that the perfect square 16 goes into it 3 times. So that is 4 square roots of 3. 27 is not a perfect square, but it does it is 9 times 3. And so I've got negative 3 times the square root of 9 times 3, which is negative 3 times 3, because I bring out the square root of 9, which is 3. Multiply it with that. Maybe that's an easier way to see it. Square root of 9 is 3, so it's just negative 3 times 3. And then times the square root of 3. And then 75 is 25 times 3. And the square root of 25 is 5. So I have 2 times 5 square roots of 3, which is plus 10 square roots of 3. So I have 4 square roots of 3 minus 9 square roots of 3 plus 10 square roots of 3. I think of it as 14 square roots of 3 minus 9 square roots of 3. That is 5 square roots of 3. Okay. Number 22, we need to multiply it out. So let's start distributing. 3 times 1 is 3. 3 times 6 square roots of 5 is 18 square roots of 5. And then we distribute square root of 3. Square root of 3 times 1 is the square root of 3. And square root of 3 times 6 square roots of 5 is 6 square roots of 15. And I can't simplify any of that, so we're done. I can't simplify the square root of 5, square root of 3, square root of 15 is just square root of 15. None of that combines. You're done. On 23, however, I have the same root, root 3, which means things will simplify. I've got negative 7 times 4, that is negative 28. I've got negative 7 times negative 2 square roots of 3, that is a positive 14 square roots of 3. I've got 5 square roots of 3 times 4, that is positive 20 square roots of 3. And 5 square roots of 3 times negative 2 square roots of 3. 5 square root of 3 times negative 2 square root of 3 is a negative 10 times the square root of 3 times square root of 3, square root of 9, or square root of 3 squared. Either way, it is 3, which makes that negative 30. So my final answer will be negative 28 and negative 30 is negative 58. And then 14 square roots of 3 plus 20 square roots of 3 is 34 square roots of 3. So there's that. So now we get into exponentials and rewriting. Write each expression in exponential form. That means just rewrite it. This is 17 to the first power being taken the cube root of, so that is 1 over 3. And this is the fourth root of y to the 10th, which means y to the power over root, 10 over 4. As a radical, the number in the denominator is the root. This is the 7th root of m cubed, so you could write it a couple different ways. You could write it as the 7th root of m cubed or the 7th root of m cubed. Either one of those is fine. If you have a negative power, remember that that refers to location, so that's 1 over the 5th root of y to the 4th power. So number 28 says, simplify each expression without a calculator. Which probably means I need my power chart. Okay. This is a negative 27, and I'm raising it to the 2/3 power, which means I'm taking the cubed root of negative 27 squared, or the cubed root of negative 27 and then squared. So here's the thing. I don't know what negative 27 squared is. I mean, I could multiply it out and figure it out. Maybe it's on my power chart, maybe it's not. But I do know that the cubed root of negative 27 is negative 3. 3 cubed is 27, so the cubed root of negative 27 is negative 3. Odd roots of a negative number are negative. So that is negative 3. And I have a lot of people writing this on the homework. Okay, it's negative 3 squared. And you need to be very careful because negative 3 squared is quite a bit different from negative 3 squared. So that is a positive 9. Number 29 is 16 to the 0.75. That is 16 to the 3/4. So you have to rewrite that as a root. Or, sorry, as a fraction, and then you can write it as a root. So it is the 4th root of 16 to the 3rd power. Always take the root first. So the 4th root of 16, I see that 2 to the 4th is 16, which means the 4th root of 16 is 2. So this is just 2 cubed, which is 8. Number 30 says 2 times the square root of 10x minus 3 times the, minus the cubed root of 10x. And as far as simplifying that goes, I don't think we can do anything. I mean, they have the same base, 10x, but, so I guess you could say 10x to the quantity 1/2, and then 10x to the quantity 1/3, but then you got a 2 in the front, that would be weird. Oh, and that's only if you're multiplying, not if you're subtracting and adding. Sorry, never mind. Yeah, we're done. Nothing I can do there. Different roots, different indices. Okay. However, this one I'm adding, and I've got 14 fifth roots of 2x plus 3 fifth roots of 2x. So I've got the same root, same radicand. That means 14 of these plus 3 of these is 17 of these. So 17 the fifth root of 2x. Number 9, it says 9x times the cubed root of x minus 3 times the cubed root of 8x to the 4th. So I have a lot of people that see a problem like this on the test, and they're like, okay, I can't do anything. And I'm like, well, okay, you should always see if you could simplify. I couldn't simplify the cubed root of 10x, but I can simplify the cubed root of 8x to the 4th. The cubed root of 8 is 2. And 3 goes into 4 one time with 1 left over. So in fact, I've got 9x times the cubed root of x minus 6x times the cubed root of x. So I can simplify it. That is 9x minus 6x is 3x times the cubed root of x. That's a 3. Should be x. And there you go. Okay, so always look to see if you can simplify before you just dismiss it. In that same vein, number 33, I've got the cubed root of 125x to the 6th minus the cubed root of 27x to the 6th. Well, the cubed root of 125 is 5, and 3 goes into 6 twice. Over here, the cubed root of 27 is 3, and 3 again goes into 6 twice, which means I'm really just saying what's 5x squared minus 3x squared, and that is 2x squared. Number 34 is a little bit more interesting, in that it's got the cubed root of 2 times the 4th root of 8. Okay, I can't simplify the cubed root of 2, and I can't simplify the 4th root of 8. But I can think of it as 2 to the 1/3 times, and remember the 8 to the first is 2 cubed, right? So that is the same thing. The 4th root of 8 is the same thing as saying the 4th root of 2 cubed, which means I'm multiplying by 2 times the 2 raised to the 3/4 power. I've got the same base, and I'm multiplying, which means I can add them. I can say 2 to the 1/3 plus 3/4, and now that I have it in one term, I can add the powers, and I need to do that by finding a common denominator. So the common denominator between 3 and 4 is 12, so I multiply top and bottom by 4, and top and bottom by 3. And that leaves me with 2 to the 4/12 plus 9/12, which is 2 to the 13/12. Now, on the review that I posted on the board, I actually did some simplification with this. This is going to be a portion that's going to be multiple choice. If you answered this right here, I would not say you were wrong. What I did was I kept going and said, well, what if you said the 12th root of 2 to the 13th? That's also correct, okay? But what if you said the 12th root of 2 to the 13th? And you're like, oh, well, 12 goes into 13 one time with 1 left over. Then I wouldn't say no to that either. Okay, so all of these are the same thing, and unless I specify how I want your answer written as a radical or as exponential, then you're okay in either of those answers, or any of those answers. Okay, number 35. So again, square root of 243, and the 5th root of 81. Interesting. So I'm just going to look at my power chart and see what I can do. 243 I see is 3 to the 5th. So I'm really just saying the square root of 3 to the 5th power, which means 3 to the 5 divided by 2, because there's an understood 2 right here. And the 5th root of 81, well, 81 is 3 to the 4th, so I'm really taking the 5th root of 3 to the 4th, which means 3 to the 4 over 5. So, if I'm doing that, then I can say 3 to the 5 over 2 plus 4 over 5. I can find a common denominator and combine them. So between these two, the common denominator is 10. I'm going to multiply by 5 on top and bottom, and by 2 on top and bottom. Leave me with 3 to the 25 tenths plus 8 tenths, that is 33 tenths. And I wrote this wrong on the review, and no one caught it until 8th period. Or maybe you caught it, maybe you wrote it down right, but then you just didn't tell me. It is the 10th root of 3 to the 33rd. So I was like, well, I can simplify that. 10 goes into 33 3 times, so that is 3 cubed. And then the 10th root, I think I wrote I don't remember what root I wrote, but it's the 10th root of, then I have 3 left over, right? 10 goes into 33, 10 times 3 is 30, and then I've got 3 left over. So it's actually 27 times the 10th root of 27. But if you left it as that would not be wrong. Number 36, it says simplify. So you can look at this in multiple ways. One way to look at it is when you raise a power and then to another power, you multiply the powers, and 2 times 1/2 is just 2 over 2, which is 1. So this is really just n to the first power. Or you could think of it as this is just a square root. So I'm saying, what's the square root of n squared? And that is, again, just n. So either way, you get n. 37, again, I could say k to the 3rd to the 5/3 is just k to the 3 times 5 over 3, which simplifies to k to just the 5th, because I got 15 divided by 3. Or they cancel out and I'm left with 5. Or you can think of it as the cubed root of k cubed to the 5th. And the cubed root of k cubed is gone, and then that is k to the 5th. Alright, so k to the 4th to the 1/2. So again, k to the 4 times 1/2. 4 times 1/2 is 4 halves, which is 2. My answer is k squared, or I can think of it as the square root of k to the 4th, which is k squared, because 2 goes into 4 twice. And then this one. This one's a little bit more interesting because I'm taking, I could distribute it, so let's do it one of 2 ways. I'll distribute a second. The way that I see it is the 4th root of 81a to the 12th to the 5th power. The other option is to distribute the power 5/4, so 81 to the 5/4 times a to the 12th to the 5/4. So I'm going to work it this way, and then we'll talk about that. The 4th root of 81, looking at my power chart, 3 to the 4th is 81, so the 4th root of 81 is 3. Okay, so that is 3. 4 goes into 12 3 times, so it's 3a cubed to the 5th power, which means 3 to the 5th power, which my power chart tells me is 243. And then a to the 15th power, so we multiply when you raise a power to another power. When you raise a number to a power and then another power. Not a power to a power. Okay. This, I'm going to have to work this similarly. The 4th root of 81 to the 5th power. 4th root of 81 is 3, and 3 to the 5th power is 243. This one I can multiply though. I can say 12 times 5 over 4, which is 12 times 5, which is 60 divided by 4 is 15. Or I could say 12 divided by 4 is 3, and 3 times 5 is 15. I prefer this method, but it's whatever you want to do. Whatever you see. And that is the end of page 2.